Let's see about the general introduction about asynchronous sequential logic and hazards. Any digital system, it can be classified into combinational logic circuit and sequential logic circuit. Combinational logic circuit output depends only on present input and memory is not required and it produces faster response. And synchronous sequential circuit output depends upon present as well as past input, memory is required and it produces slower response. A sequential circuit can be classified into two types, synchronous sequential circuit and asynchronous sequential circuit. This is the overall difference between synchronous and asynchronous sequential circuit. Synchronous sequential circuit, memory elements are clocked flip-flop, and asynchronous sequential circuit, memory elements are either clocked, unclocked flip-flop or time delay elements. The change in input signal can affect memory element upon activation of clock signal. In asynchronous sequential circuit, the change in input signals can affect memory element at any instant of time. Synchronous sequential circuit easier to design, asynchronous sequential circuit more difficult to design. So this is the overall block diagram of asynchronous sequential logic circuit, which mainly consists of combinational input and output is fed back to the delay element and that is feedback to the input of the combinational logic circuit. Based on the input variable, asynchronous sequential circuit can be divided into fundamental mode operation and pulse mode operation. In fundamental mode circuit, inputs and outputs are represented by levels rather than pulses. In pulse mode circuit, input and outputs are represented by pulses. And then next let's see about the hazards. So hazards is nothing but unwanted switching transients that may appear at the output of a circuit because different paths exhibit different propagation delays. Hazards occur in combinational circuit when they may cause a temporary false output value. It causes malfunction in the circuits. It mainly occurs in asynchronous sequential logic circuits. Hazards, it can be classified into three different types: static hazard, dynamic hazard and essential hazard. Static hazard, in digital system there are only two possible outputs, 0 or 1. The hazard may produce a wrong 0 or a wrong 1. Based on this observation, there are three types in static hazard: static 0 hazard, static 1 hazard and dynamic hazard. Static 0 hazard, if the output momentarily goes to state 1, when the output is expected to remain in state 0, it is known as static 0 hazard. Static 1 hazard, if the output goes momentarily to state 0, when the output should remain in state 1, it is known as static 1 hazard. Dynamic hazard, in which output changes 3 or more times when it should changes from 1 to 0 or 0 to 1. And then last one is essential hazard. An essential hazard is caused by unequal delays along 2 or more paths that originate from the same input. Essential hazards can be eliminated by adjusting the amount of delays in the affected path. To avoid essential hazards, each feedback loop must be handled with individual care to ensure that the delay in the feedback path is long enough compared with the delays of other signals that originate from the input terminals. In next video, let's see about how to eliminate hazard in combinational logic circuit. Thank you.